So, when you are solving equations, as you did in the past, you still want to draw your dashed line down through your equal sign to make sure that you keep those equal signs lined up. So I'm going to do that first. If you notice, though, there's a lot more on each side of the equal sign than there was when you solved the two-step equation. So what you're really going to do here, and let me get a rectangle instead of a line, is it's like you're totally ignoring the right side of the equation for a minute, like it doesn't exist, and I look at the left side of the equation to see if there are any like terms that I can combine. And there are. I have a 5m and a minus 3m, and 5m minus 3m is 2m, and then bring down my minus 10. My equal sign is still over here. Now, I can't simplify 2m minus 10 anymore by combining like terms because this has an m and this doesn't. So, ignoring the left side of the equation for a minute, let's look at the right side. I have two constants. I have a 14 and a plus 21. So I'm going to bring down my negative 8m because of the minus in front of it. And then positive 14 plus 21 is a positive 35. So I end up with negative 8m plus 35. Now I'm going to move that out of the way for now. We'll use it on the next problem in a minute. At this point, I have both a variable term and a constant on the left, and a variable term and a constant on the right. I want my variable terms to be on the left side of the equation, and my constant terms to be on the right side of the equation. So I don't want, on the right side of the equation, this minus 8m. To eliminate a minus 8m, I'm going to add 8m. I'm not trying to just get rid of the 8. I'm trying to move this entire term to the left side of the equation. So then I'm going to add 8m here. And yes, you have to have the m's on these. You're not just adding 8. You're adding 8m. So 2m plus 8m gives me 10m. Bring down my minus 10 equals a positive 35. Now I'm going to move the constant to the left to eliminate a minus 10 constant on the left, or to the right. To eliminate a minus 10 constant on the left, I'm going to add 10, which means I'm going to have to add 10 to the right side of the equation, and I end up with 10m equals 45. Once I get down to a single variable term equals a single constant term, then I look and say that 10 is connected to the m with multiplication, so I need to divide by 10 to isolate the m. In this case, I get the exact decimal m equals 4.5. I could also give this as a mixed number, m equals 4 and 1/2. So this second problem, again, dash line down through the equal sign to keep my equals lined up. For a moment, I'm going to ignore the right side of the equation and just look at the left side. And what I notice is I have two constants. So the 10x is going to come down. And then if I take my calculator and I punch in negative 6 minus 8, I get negative 14. So I'm going to write minus 14. On the right side of the equation, I also have two constants. I have a positive 4 and a plus 16. So I'm going to bring down my negative 8x because of the minus in front of it. Positive 4 plus 16 is positive 20. So I'm going to write plus 20. At this point again, I don't want this variable term on the right side of the equation. Since it's a negative 8x, I would add 8x to eliminate it on that side, which means I have to add 8x on the left side as well. And I end up with 18x minus 14 equals positive, because of the plus in front of it, 20. I don't want this minus 14 on this side, so I'm going to add 14 to that side, which means I have to add 14 to the other side. And I end up with 18x equals 34. Now that I have a single variable term equals a single constant term, I look, the 18 is connected to the x with multiplication, so I need to divide by 18 to isolate the x. This is a situation where it says give exact reusable answers. I cannot give a decimal answer. Here I could, because m was exactly 4.5. But here, I have to convert this to a fraction and reduce it. X ends up equaling 1 and 8/9.